Hello, everyone. It's great to be here. Thank you, Matt, for having us. I am Anna He. I run business development at a machine learning company called HyperScience. I'm here with our CEO, Peter Brodsky, and we are going to talk a little bit about how the work we're doing in workflow automation extends beyond just back and middle office efficiencies and actually drive a lot of impact in front office, customer experience, and various other ways where the business actually works a lot better. I'll spend some time today giving some background on the company and what we do and the products that we've built. I'll also talk about some of what I just alluded to in terms of the promise of automation and how we're kind of fulfilling that promise, and also talk about some concrete use cases of our product. Then Peter is going to dive into some tech observations from the work we've done thus far, as well as some lessons learned. So in a nutshell, HyperScience is a machine learning company using all of the buzzy technologies that everyone loves to talk about to automate exceedingly boring office work. Essentially, we want to turn something that looks like this into something that looks more like this. The first area where we're starting is all around paperwork processing. So stay awake, but paper is alive and well in a lot of different verticals and a lot of different types of businesses. And so a lot of times you have an army of hundreds of people sitting somewhere that looks like this, basically just typing in data off of documents into some kind of database to enable further downstream processes. We've really worked on kind of pulling the latest cutting edge technologies to address that and automate that, which we'll talk more about. In these paperwork processing workflows, some of you might even be responsible for one of these, but you kind of have this predictable workflow around scanning paper documents in. So you are a wealth manager and you have new account opening forms coming in or change of address forms coming in. They all come to some centralized place where they get scanned in and digitized. But that image that is digitized is probably some static PDF that you can't search or can't get any data off of. And so that necessitates manual data entry. Before you even get to the manual data entry, though, you have to understand what kind of document you're looking at. That also takes a lot of manual labor. Someone needs to say, yep, this is a new account form, this has to do with retirement, this is a monetary transaction, this is a non-monetary transaction. There are all these kind of sorting steps to be had before you can even get to processing the actual document. Then there's the keying itself. Manual keying has stayed around even in our digital-first, mobile-first world because a lot of times you have things coming on paper that are handwritten and hand-printed, and there hasn't been any good technology to be able to take that information and read it and turn it into something that's machine-readable. And then our product obviously needs to integrate and play nicely with other things within an enterprise, and so we've really spent a lot of time on making that integration as seamless as possible as well. This is an actual screenshot of our product. Like I said, it's boring, but it's also straightforward. It takes a document like you see here on the left. The machine is able to automatically understand what type of document it's looking at. You can't see this here in the static image, but if it comes in skewed at a 45-degree angle and it has crazy scan marks on it or it's crumpled up, it actually has the ability to uncrumple and straighten out the document as well so that it can go about its business and transcribe the data off of the form. The transcription, you see some UI on the right to show you how it works. We handle the handwritten entries on here, the hand-printed account numbers here. That was a fun exercise trying to solve that because, as you can see, the account numbers are printed in little boxes. So there's some work around training the machine to not read the lines in the boxes as ones, which is an interesting problem to solve. You see checkboxes, you see signatures. But that's our product in a nutshell. It takes things that were formerly only human readable and therefore necessitating a lot of manual workflows and makes it machine not only readable, but then understandable and also operable. There's some interesting nuance to what we do. So to dive in a little deeper, you can see here on the left there's a bit of handwriting. It's nice handwriting. It's easy for a person to read. But if you guys aren't familiar with OCR technology, it stands for optical character recognition. That's been around since, I think, the 70s. And it's just not a very resilient solution. So it kind of needs pristine conditions on the page, good contrast between the font and the background. Maybe it needs to be in a special printed text. And it definitely can't handle something like handwriting here because you can see it's kind of half cursive and half print, and you don't really see where one letter ends and one begins. So trying to read that character by character falls apart pretty quickly. You can see that on the right with some of our competitors. This is a live demo we usually do, but Abby is a kind of common name in the space. You can see that they don't do such a hot job at reading what's in the box. Google's known as state-of-the-art, but they are not particularly good at this problem. Tesseract is a legacy open source solution. They don't pretend to do handwriting, but it's clear why. And in contrast, you can see that when we ask HyperScience to read what's in the box, it actually does a good job. And what that enables is actual automation. If you installed something like an Abby, you might have tried to give it a shot, but you probably got tired of correcting the output from the Abby engine, and you decided, maybe I'll just type it all myself. So in a nutshell, what we're working on is at the intersection of the hard. It's cutting edge machine learning technology, things that Peter can speak more to. It's also extremely valuable, and it's also extremely boring. And that is a core thesis of our company, that at the intersection of those three things, there's a ton of opportunity, and that is where we are playing. In terms of why this matters to companies, I think workplace automation is obviously a super trendy topic, as is digital transformation. And we're at this point where these large enterprises have kind of picked the low-hanging fruit on their digital transformation journeys. You have insurance companies say you can file a claim online, banks say you can open an account via your mobile app, and all of that is great. But we have gotten to the point where you kind of need to dig deeper in order to enable further digital transformation. Essentially, it's getting hard to convince a customer that the experiences that they associate with one-click purchasing from Amazon, calling a cab at the tap of a button, or downloading instantly via Netflix, these are truly digital experiences that it's getting harder and harder to convince customers that you are doing if what is powering your actual processes looks more like this. There's a lot going into having very paper-driven processes and serving your customers well. A lot of times the manual work is a lot slower, and so there's a true risk there if you don't turn around results to your customer in time when they're expecting more and more instantaneous on-demand results. You eventually end up losing those customers. There's a reason why we went from this to this. It's not only faster to build a better product, but it's also cheaper. And so the implications there are, automation really help you deliver more value to your customer for less money. And there are obviously errors. Manual work is done by humans. Humans are error prone. And the impact of these errors can range from aggravating, if it's your DMV application that got messed up and you don't have a driver's license for another couple months, or it can be life-threatening when someone messed up your disability claim or didn't get back to you on time, and while you're waiting around for the disability check, other things happen. So obviously, for all these reasons, it is imperative for organizations to really think beyond that kind of mobile app, fancy front-end layer of digital transformation, and think more holistically about how middle and back office processes also power those experiences for customers. And so that gets back to the promise of automation that I alluded to earlier. Any kind of technology advancement and automation promises to do things faster, cheaper, and better. One way that our humble forms processing product that enables people to do things faster are things like processing a mortgage application. We have a customer who used to take 8 to 10 days to turn around a mortgage just because of all the manual exception handling and processing that it takes within that application process. And they're using our product to cut that down significantly and get back to their customer within maybe 24 hours. That obviously allows them to win that loan, prevents them from going to a competitor, and so there are a lot of effects there. In terms of doing things cheaper, the amazing thing about our product is that the ROI is very easy to see. You go from, like I said before, manually typing in all of the kind of fields that are coming in on every single form to really only needing to supervise a machine doing it on the exceptions that it generates. That is a dramatic increase in productivity and throughput, and it's allowing our insurance customers who have these backlogs of claims, for instance, that they have to process to actually get through them in a more timely fashion. An example of where we're helping companies do things better is another example from the insurance space. These insurance companies, especially the legacy incumbents, they sit on years and years of incoming forms. So they have large image repositories of where they have scanned images of the claims forms they have coming in, the policy submissions, any other kind of supplemental documentation, and it's just sitting there. Obviously, the underwriting team and the data analytics team, they are really motivated to unlock all the information that's trapped on these documents that is previously human readable to feed their models and their pricing and analytics engines and come up with new products and serve their customers better. But it doesn't make sense for them to hire an army of people to manually type them in. So a really interesting use case for our product is kind of going through, automating that whole process and really driving more product and service opportunities within those kind of organizations. That story in insurance is true across a lot of these verticals, right? Financial services, like I mentioned, healthcare. There are upstarts that are doing a lot better, at some of these processes. So using a technology like ours to update kind of out-of-date processes is imperative. With that, I will turn it over to Peter.
All right, I'll talk mostly about tech. Oh, right. How's now? Is this any better? How about now? Anything now? There we go. All right, so I'll talk mostly about some high-level tech observations for a couple minutes. The first is a somewhat counterintuitive idea that if you specialize on something, if you really focus, you'll do a better job at it. It turns out that's not quite true. It turns out that it's really helpful to have the context. Like if you're made to guess what that is, you might have a tough time. But if you're given a little more context, sort of the picture comes into focus and you can start to see what's going on. This is particularly true for the handwriting example that you saw earlier. It seems like a really simple problem, but having a model of the way the world works, a correct model of the way the world works, really ends up helping you with a problem as simple as this, where if you look at the word in the box that says the, it could just as well say he with a capital H, or maybe she with a cursive S. The reason you don't think that it's either of those is because you know something about English, you know something about the world, you know something about what that sentence might say. And so it turns out that by not focusing your machine learning models on too narrow of a problem, like character recognition, but really enriching the way that that model works with additional information, you end up getting vastly better performance. So that's somewhat counterintuitive. The next bit I wanted to share is the way that you layer those things in. Traditionally, if you have a simple model, looks a little something like this. You say, well, why don't we add some stuff to it? Then you add some more stuff, and you go from having something that's useful to having something that's kind of useless and not particularly wieldy. The same ends up being really true for our machine learning models. It ends up, as some of you probably know, that if you want to combine an understanding of the way the world works with the way that you read characters off a page, it ends up being one model that has to do all those things. And if you have a model that tries to get characters and another model that like spells check that, you kind of get garbage results. The third observation that we had that I think is somewhat counterintuitive, at least if you come out of academia, is that model performance is definitely not everything. A lot of competitions, especially machine learning competitions, are around who's got the best performing model. The reality is that actually there are a ton of trade-offs, and it's important to know when something isn't going to work, not just having it work. And that is really kind of critical for the way that we get, again, good performance, where the system says, all right, we're going to get this one wrong. It knows it's going to get something wrong. It knows that what it's about to do isn't going to work out. It calls for human help. The human intervenes, and we get end-to-end good performance. And so it turns out that being confident about just how right you're about to be is, in some ways, just as important and sometimes more important than being right on average, which is kind of surprising. This is really the blooper reel. I'll go really quickly here. The first is if you show up, everybody talks about data. This is a data-driven event. If you show up to your customer and say, give us all your data, and 6 to 9 months later, maybe we'll show you results, and we'll probably need to charge you $1 million, not because we're making money, but because that's how much it costs to do this. You will not, it's like not a good message to send. Like, your customers aren't going to love you. And so you actually have to come with your data, or batteries included. In this case, is data included. You don't want to do custom work. There are a whole bunch of reasons for this. The biggest one is that nobody knows actually how to do custom work. Custom work is basically a new product. Shipping the Model A products to your customers is always a disaster. This is a really well-known cartoon. And it pretty much ends up exactly like this. And then the last one that I'll share is cloud. Everyone talks about going to the cloud and everything's going to be hosted. No one's going to give us their data because we're a bunch of no-name nobodies that nobody's ever heard of. And so if you're a big bank or a government or anybody else for that matter, you're probably not going to give us your data. And so the data has to stay on-prem. Nobody's going to the cloud. And so from a business model standpoint, we do something called neoclassical SaaS, which is it's on-premise, it runs on your machines, and we charge a recurring license, which is sort of a surprising thing if you are a tech company and you're sort of used to doing everything in the cloud. That's pretty much it. Thanks for listening.
Great, and it's interesting, right? Because we, as a group, we're so excited about the premise and progress of machine learning, AI, and all the cool things, flying cars, and whatever AI is supposed to do. But the reality of AI is very much this, right? It's a core business process in the enterprise that costs a lot of money, and that can be automated. That's the reality of AI today, right? That's what it can do. One aspect that we touched upon is how you train the system and the data strategy. Maybe you can touch upon this a little bit.
Sure. There are basically two approaches that we take. One is we obviously take great lengths to generate our own data. We've got a synthetic data generation system. We've got a program that will take a very small sample of a real person's handwriting and then forge that handwriting and write whatever we want, which is kind of a cool trick. But it is also obviously useful to train these machines. And then we've got a technology that we're working on that allows us to not take customer data, but basically train on premise and then take the models that we've trained and reuse them, even if they're on fundamentally different kinds of problems, which is particularly exciting.
Only one mic.
Two-part question because of the neoclassical SaaS, which you mentioned, has been a problem earlier in the financial industry too. ServiceNow came to facing the same issue. So first they started off with what they had and eventually graduated to SaaS. On your front, how does your learning continue if you're doing a neoclassical SaaS? And how do you give them the benefits of economy of scale?
Okay, so there are two parts to that answer. One is that there's on-premise learning that happens. So the vast majority of the performance is out of the box, which is really helpful if you want to convince your customer that you have something that works. So the vast majority of the performance you get on day one. Obviously, the system continues to learn on-premise. When we do upgrades, some of our customers participate in something that we call data dividends. And the idea there is that we never take the data, but we take the models that have learned on that data, and we take those home with us. It's a give-to-get model. So if you don't want to participate, that's fine. You're going to have slightly worse performance. You can decide for yourself what's appropriate for you. And that's sort of the economy of scale, if you will.
you. So, my name is Michael. Last week I was in a mine in Pennsylvania for 3 days where they do almost nothing but process paperwork. Data entry, scanning, turning it back into a PDF. I mean, it's really incredible. And my job there was to say, well, we kind of determined on our own, it's our job, like, to get them off of paper entirely. Why, for us, we were like, we could OCR some of this, we could find a way to, archive it in another fashion, but, why not just create the web form? Why not just, for us, that was the definition of transformation. So, how are you approaching that decision to mirror the paper process, but in digital form? So kind of replacing Conway's law with AI versus actually transforming and digitizing that whole experience. How are you managing that trade-off with your clients?
So there are a couple of parts to that. So first of all, obviously everyone, like I said, is moving toward digital first and mobile first, but the reality is paper is around to stay for a while. You have the lagging customers who are never going to get off of paper. But then you also have this coordination problem, for example, in the insurance industry, where even if you as an insurer want to go completely digital and make great strides there, you are working with a whole network of TPA, third-party administrators and brokers and agents, and they all do their thing their own separate way. And so unless you can say, all right, industry, today's the day, we're going to go paperless, it's not going to happen for a while. The other piece of that is that we want that vision of just going completely digital forms. A lot of the paper we deal with actually doesn't touch physical paper, right? It's generated on a computer by some person filling out an online form, and they submit it. It never got printed out or scanned or anything, but it's still some definition of paper, and it's still human-readable content, right? And so because people are going to be operating on human-readable content kind of by definition, we believe that the translation layer that we provide for that type of content to machines and then back to humans is going to continue to be valuable.
All right, wonderful. Thank you very much.